Alright, so welcome to part one of TJ trying to make his own HDMI circuit for the Atari 2600. So first step is to fix the Atari 2600 so that it outputs video. So when I power this device on, that's what I get on the TV. So I'm fairly certain, and this power switch is a bit, that power switch is a bit flaky, man. Alright, so now it's not doing anything. Alright, now it's back to that. I'll power it on again, and now I get that. So this thing definitely has some issues. Let me try to find a different game. So I have like 40 games for this thing, man. I bought this. I won this in an auction for like 50 bucks, and it came with like 30 games, and then I had some from before. So let's try this game. So this is good old Star Master. Alright, so it's doing something. Star Master's doing something. So when I press the joystick isn't doing anything there. And there's no sound. I have zero sound, but it is reading the game, so that's promising. So no sound. Let's or I don't know if these things are supposed to have sound. Let's try this Skyjinx or whatever it's called. And it looks like it gets stuck. It gets stuck like that. Let's try Spider Fighter. So that one works, man. But I can't start a game. How do you start a game, dude? I don't know how, I can't remember, dude. I was like 8 years old when this thing came out, so it's been a long time since one of these I'm pretty sure is the reset, right? Alright, so I think the first thing I want to do is to sort out this power button issue. I don't know how these things come apart. Dude, it would be nice if this would just unplug. Oh, it does, dude. It does unplug. Look at that. That is nice, man. Okay. So I bet that it would be nice to replace all of these capacitors as well. So I think we're going to try and sort out some switches, because like when I would barely touch the power switch, it would flake out. So I think maybe bend these prongs, maybe. How do you take these off? So oh, I didn't mean to do that. How does this work? Oh, you know what? These just go in there like that. So those go in there like that. So yeah, I guess the best way to do this would be to take this. I'm going to dip it in alcohol. Get some of that oxidation off of there. Or maybe they go like this. Maybe they go like this. So maybe I need to sand. Yeah, that makes more sense. So they would go in here like this. Yeah, that makes sense. Okay. All right. So put that in there. Let's put that in there. Tilt this up. Oh, Broham. Oh my goodness. So now, yeah, that's much better. All right. So now let's fold. How am I going to do this? Let's fold this. I didn't think this part through. How do you do this? Ooh. Okay, I think that's good. So with that being said, I am going to do the rest of these to make sure we don't have any problems with. That way we don't have to worry about a switch being potentially bad. So I'll do that, and then we'll pick up when I'm finished. Alright, so I have it back together, plugged in, and when I power it on, we are still getting a gain. Now that I've cleaned the buttons, when I reset the gain, now notice, oh Lord, I can't. I can play the game now. You just stay in one spot, bro. That's the trick to whatever this game is. All right, so that's at least fixed. So now the issue is I still don't have sounds. So I need to figure out the next thing I need to try. Well, first of all, I think it's stuck on like super high speed mode. Because, dude, it's just nuts, man. I mean, there's no reason that thing should be that fast. It's just way too fast, bro. But this button here is the high speed mode. And I don't think it works. So I need to readdress that one as well. So anyhow, we're getting closer to that. So I'm going to go ahead and disassemble this and make sure that I didn't put it back together wrong or something like that. So if I'm being honest, I may have forgotten to take this one off. Ooh. That capacitor still had a little bit of charge in it. I bet it don't have none now. And I'll tell you, these definitely need to be cleaned because when I took this one off, I didn't take this one off. I figured out that if I squirted some alcohol in the back and just kept doing that, eventually, because the way these work is it's normally up with a spring in there, and these two pins are shorted. You can't see. These two pins are shorted right here, and then when I hold the button down to reset the game or whatever the case, I wasn't getting a short on these other two pins here, and so that's why I couldn't start a game earlier, because I couldn't reset the game to actually start a game. But yeah, so I got those squared away pretty well, and this one works how it's supposed to. So when I flip it up, these two pins are shorted, and then when I flip it down, I think it's this pin and this pin are now shorted. I think that's how that's supposed to work. But oh yeah, because that's always shorted. Oh, I get it now. Yeah, that makes sense. So yeah, so this one works like it's supposed to, but this one here was not working the way it was supposed to, and that is the game difficulty. And bro, listen, I ain't trying to play the 1980 game on extreme difficulty. I wasn't that talented as a boy, and I ain't that talented now. So I think that's all we really need to do on those. Oh, come on, bucko. These things, man, are a pain in the neck to actually get on there. I'm just trying to wedge these in here to bend those tabs and to keep them tight, you know. So let's so we have it in the up position. So the up position is going to be shorted, which it is, right? And then but the bottom position should not be shorted, but it is. That's what I don't understand about this specific one. Why is it shorted? That's shorted. Not shorted. shorted? It's not shorted. It's shorted. It's not shorted. Okay. Alright, so I think that's better than what it was doing. Alright. Sound. Why don't we have sound? Actually, let me go test this one more time. Alright, great news. I think there is a slight difference. So I think, okay, so all my buttons now function, or my switches function as they're supposed to. So we need to figure out why we don't have sound. So that'll be the next thing we do. Alright, so I need to move these games out of the way. So every one of those games needs to be tested. And I gotta tell you, I am not looking forward to that. But, so where are we at? So it's been a few days. I got busy. So we left off, we didn't have audio. So we're gonna probe the audio circuit using our oscilloscope and see if we can discern if we have audio coming out of our TIA and see if it's making it through the circuit in some way. So that's what we're going to do next. So we're going to go ahead and turn on our console. We're going to check pin 12 and 13, which is, I think this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's 12. Oh my goodness, what is that, bro? Let's hit the auto set. So that is just a sine wave. Let's check pin 13. Pin 13 is nothing, so perhaps I'm on the wrong pin. So that is, now we don't have anything and nothing. Do I not turn it off, turn it back on? We get nothing. If I start a game, what do we get? Let's auto set. Okay, we're getting something. We're getting something. And we're getting something else, but it's just really, it's just really big. Okay, there we go. So we got a sine wave there. So I don't know what that is. So if I start the game, does anything change? Nothing changes. So let's go to, I think it's this capacitor right here, and you can't see anything, so let's auto set, see if we can see something. So we just get 5 volts there. So we have nothing there. We have nothing there. Let's turn it off. Let's turn it back on. We get nothing. We're getting nothing. There seems to be something intermittent going on here. I'm assuming it's on. I'm assuming it is on. Do we have 5 volts? So this is ground. We've got 4.8 volts from our voltage regulator right here. So we know at least we know that we've got voltage coming in. So that hasn't changed. We got 3.4 volts there. 4 volts coming in. So 4 volts is making its way through the circuit into the circuit board. So which one of these is 4 volts or input voltage for the chip? Right here. Okay, so we've got 5 volts coming into our TIA chip. So we know we got voltage. Maybe I didn't have the ground. Maybe I didn't have it grounded properly. Maybe that's the issue. We get nothing there. We get nothing there. So is that digital audio coming out now? So let's turn it off. Turn it back on. We get that. Does it change when I start the game? Because you don't get sound until you start. Oh, I saw something. So we're getting something. If I come to this capacitor, let's auto set that. Okay, there we go. Okay. We were getting something. Let's set the time down some so we can see what's going on. Yeah, you can see, so we know that we are getting sound, or the digital representation of sound that's being outputted by the TI. Ooh. Yeah. Alright, so we know that's good, right? So if we come to the other side of this capacitor, which the audio goes through, notice how the waveform changes. And so since it's moving around and acting kind of strange, or it looks like sound. You know what I'm saying? It looks like a representation of something changing. So when I do games reset, you can see it starts to do that. So then from there, but notice how it changes from here. We've got a square wave. We've got a basically a square wave. Yeah, so that's definitely sound. Yeah, that's pretty cool, right? So those highs and lows represent various tones or whatever that the game's putting out. So if I come to the other side of that capacitor, notice how that waveform changes from a square wave, basically with, you know, positive 5 volts and 0 volts. It changes to a different type of waveform, and I think that's because that capacitor is acting as a low pass filter. So yeah. So from there, bro, you gotta pay attention so you don't short anything out. So let's reset the game, and we can see we get sound again. And so, oh, I know what's happening. As I start the game, and then my dude just sits there and dies 5 times, and then the sound stops. So then when I come to this resistor right here, and it may be easier for you guys to see if I do the microscope, so you can tell what's going on. Let's do it that way. All right, so this is the output of the TIA right here on this pin I have marked. That's going to be my square wave. And then it comes over to this capacitor as a square wave, right? It goes through. Oh, you know what? Let me show you. Let's move the oscilloscope back. So it's this capacitor right here, C210, maybe that is C210. Yeah. So I come here and I get my square wave, and then on the other side of this, I get that funky looking wave. It's been filtered. So the square wave has been filtered now to a different type of waveform that is not square. I don't know exactly what that would be called, but so anyhow, so from there it goes into this capacitor. Oh, let me reset the game because I died. It goes into this resistor here, and then on the other side of that resistor we should have, notice it's a lower it's a lower voltage. So you can see the variations in that waveform. So then from there, it goes to, I think this capacitor on the other side of whatever chip that is right there. So I think it goes to here. Let me see if I can't find the schematic. All right, so the audio comes out pins 13 and 12 of the TIA. It goes through C210. Again, I'm assuming that's for low pass filtering or high pass filtering, or as you were. Yeah, high pass filtering, I guess. And then it goes through an 18K R209, which drops the signal down to a lower value. And then you have Q202, which I don't exactly know what it's doing. I don't know, because the base of this is 5 volts. You're going to have 5 volts on the base of Q202, which is going to forward bias that transistor, which would then, I don't think it's for amplification. How could you amplify that way? I don't know. I don't know what that does. And then it goes to C211, which is, again, I don't know what C211 is doing. Maybe taking the DC component off of the signal. I'm not really sure. And then it goes to R216. So if we go back to, and we look, so we know that the pin 12 and 13 are these 2 pins right here, right? And then it goes to C210, which is this capacitor right here, right? It goes through this capacitor. Then it goes to R209, which was that resistor that presumably is there to decrease the voltage from the input to the output, which I think we saw that it did. And then from there it goes to C211, which is this capacitor right here. And then from there you notice it goes to this other resistor, which is R216. And then from R216 it goes to pin 4 of the modulation circuit, which is pin 4 is right here on the input to the modulator. So let's trace that again. Let's trace that again and see what we get along the way. So I'm going to put the gain back in. So again, let's just start from scratch here. We're going to cut it on. We're going to come to pin 12 or 13. I'm going to set my auto set. See if we can see something. And we don't see anything. Let's start the game. We don't see anything. I mean, we see something, but it's small. But if we go to C210 and we auto set it, and we change the voltage, we notice we're getting audio. We're getting audio. And then if we go to the, oh, you guys, I keep forgetting to move this stupid thing. If we go to the other side of C210, we get that signal. If we go to this resistor here, which is R209, we get the same signal. If we come to the other side of R209, which is right here, notice the signal is, it looks this way on one side, looks that way on one side, but then on the other side, and it's writing 5 volts, right? It's that signal is writing 5 volts DC. If we come to the other side, it's still writing 5 volts DC, but the signal seems to be more compressed. And then from there, it goes to, and you can't see it. Let me see if I can't tilt it goes to R211 or C211, which is right here. And it's the same signal because it's a direct short from that resistor to here. It goes through that, and notice it's squished a little bit more. So it looks like this. It looks like this, and then on the other side, notice it's still writing 5 volts, or in this case like 4 point something volts, or maybe even 3 point something volts. But it's smaller. The actual waveform is smaller. It's just writing DC. And then from here it goes to this resistor, and it's the exact same because it's a direct short between that capacitor and there. And then it goes to the output, which is even smaller. So on this side of the resistor, I'm trying not to touch everything while doing this. On that, let's restart the game. And it's so small you can't even see it. But right there, we have, so it's still, we have the signal there, and it's sitting right at like, because I've got this set to 2 volts per division, and there are basically, it's writing up to 2.5, so that would make 5 volts, right? So we have an AC waveform writing on basically like a 4.2 volt DC rail, and on the other side of that, it's now writing, it's still an AC waveform. You can't really see it, but it's now writing on like 3.8 or something. And then it goes through this resistor, and on the output of that resistor, it's still sitting on that same, it's just smaller. Between here, well, no, it's about the same, I guess. No, it's smaller. It's definitely smaller. It's definitely smaller. So, and then from there, it goes to pin 4 of the modulator circuit. It goes to pin 4 of the modulator circuit as that same level. So that, I don't know exactly how to tell. I don't know how to make that. I don't know how to do that. I don't know how to make that bigger. What is channel menu? What if I did AC coupling? How do you go up to AC? Let's go to AC coupling. Oh, I see. So can I make that bigger now? I can. Oh, look at there, dude. Look at that. So if we, can I make it, can I expand it some? No, that's the wrong way. We want to make it bigger. So that's our audio. That is our audio. That is pretty cool, man. So, yeah, so I got to remember that. AC coupling and DC coupling. So we can see, with DC coupling, we can see that the waveform is riding on top of DC. Whereas this, we can actually look and say, okay, so we've got it set to 1 volt. Each division is 1 volt. Gosh, man. So let's stop it real quick, and then let's like measure this. So if I increase this up to And I don't know how much of that's noise and how much of that is the actual audio. I don't know if the waveform in the center is audio, or if all of it is considered audio. But we look like we're sitting at, if it's 1 volt per division AC, that means that we're sitting at like, you know, if I just go with the actual sine wave, and I go from the bottom of the sine wave to the top, we're sitting at like 0.8 volts peak to peak. Does that make sense? So we're sitting at like 8 volts or 0.8 volts peak to peak. So to me, it looks like audio is making it all the way to the modulator. But the problem is I don't know. Let's go ahead and resume that. The problem is I don't know if I can check coming out of this. I don't know how to check. I mean, I get something there. Let's restart the game, and let's make this bigger. Volts per division. Let's spread this out some. Let's make it bigger, maybe. So I'm assuming that is what, that's our signal that would go to the TV after it's been modulated. And I don't know how to see which part of that's audio and which part of that is, I think I would have to actually look inside the actual modulator thing itself. So the only thing I can think of is that either my modulator's bad or it's something to do with my TV. But people complain about hooking these up to like an LCD TV or whatever the case may be. But I'm just using the normal cable with one of those RCA to BNC adapters, and I've got the TV tuned to find the Atari, and the picture quality looks good. You know, I mean, it's clear. It's, you know, whatever. I did not clean this switch, so maybe this is the channel select switch, and I didn't even notice it because it's like it's buried up in there. But maybe that has something to do with the issue. So I think I'm just going to squirt some. I ordered some deoxit. So we will see. I will put some deoxit on all of these switches when it gets here. That's the only thing I can think, because I mean, if it's not tuned to the correct frequency, you're not going to get audio, but you may get some picture. So yeah, I don't know how to take this switch off. I don't think I'm gonna. I think I'm just gonna do this a bunch of times with some alcohol, squirt it in there, and see if maybe, because every other switch was bad. Every single switch on this thing was bad. Maybe this one's bad too. All right. So I'll let that dry, and then we'll hook it back up to the TV, and then see if we can figure out how to get sound out of this thing. Because I don't think this is bad. I mean, the picture quality is too good for this to be bad, you know? I mean, I could see if the picture was fuzzy or whatever, but it's not. It's clear. So, yeah. Anyhow, let's let this dry, and then we will hook it back up to the TV. Alright, so I have the TV on. I have it plugged in. So let's see if we still get signal after all my probing. And we do. So let's start the game, see if we get sound. And there you go. It was that switch. It was that switch the entire time. That switch right there, the channel select switch. Unless I probed around in here and I just died. And maybe made a connection that wasn't making it before. So maybe I should go through and touch up the solder joints on the back of this thing. So yeah. So all right. So let's go back over to the bench. All right. So now that we have a fully functional Atari 2600, we've made sure that all the inputs work. It plays games, it produces sound and audio. My ultimate goal of this series, if you want to call it that, is I want to design and build my own HDMI circuit for that Atari 2600. So steps that I've taken is I fixed the Atari. And when I say fixed, it was just button or switches that needed that weren't making good connection. So the next step is to design my own composite mod, which means that I need to, let me move this down some. So I want to design my composite mod, and so I'm going to do that by ordering a circuit board from PCBWay that I've designed using KiCad or whatever free computer-aided design software I can find. Order and install the components on the board that I design and create, and then test that with my RCA cables, with the yellow, red, and white cables. And the reason why I want to do this for the composite mod piece is because, first of all, it'll teach me how to learn how to design a circuit in computer aided design, but it'll also allow me to order something from PCBWay, figure out how that works, how much it costs, all that kind of stuff. And I do realize that, obviously you can just do a composite mod and then plug that into a $13 RCA to HDMI adapter, but that's not the point. The point is I want to learn how to do that. So once I do that, and I ensure that my composite mod works and it'll output composite video, I then want to decode the composite into, I suppose it would be component, it would be RGB, because in order to interface to HDMI you have to first have a digitized signal. So I am going to, I found a chip, it's the TV, I think I have it. So I've done a bunch of research, and I think that this chip right here, the TVP5150, is a NTSC, PAL, and CCAM decoder, which you can see right here. And so my plan is just going to be to take this, use their example, or start with their example recommended circuit layout, and then design that in the KiCad, and then and so that basically I'll expand upon the composite mod to convert it to composite, and then interface that to the decoder, to the TVP5150. And again, I have no idea if this is going to work or not, but this is where my knowledge is currently at. And then once I get done with that, then I will figure out how to interface it to HDMI. And I don't know if I can go directly from the output of this chip to the input of an HDMI transmitter, or if I have to do something in between. I don't know. I don't know. But I do know that it can't be that difficult, because I have taken an Atari 2600, installed a composite mod that I got from eBay for $12, and then ran that through one of those little $13 adapters, and it worked fine. It produced perfect video. So yeah, so that's where I'm going to go with this. And the first step was to fix the Atari, and we've done that. So the next thing I'm going to be doing is using the oscilloscope to look at the luma, because with composite, and we'll discuss this when we get into this piece of it, but you have your 3 luma signals, which are your brightness. You have your color, which is a signal that represents the color, I suppose. I don't fully understand it, but and then you have your sync. You have 1 sync pin. And the idea with composite is to combine all of those things as an output from here, and that's what would allow you to either use S-Video or use your RCA, your yellow, red, and white RCA jacks. So anyhow, so that's where I'm going to call this video. We've got a lot done. The Atari's fixed. I am going to order some capacitors and replace that voltage regulator. I'm going to replace those capacitors that look like they're 40 years old or whatever. I'll replace those just to be safe, to make sure that I can get the best working Atari 2600 that'll generate quality signals that I can. So anyhow, so I appreciate y'all watching, and hopefully we can figure this out, and then if I can figure it out, you'll know how I did it, and you can do it yourself. So that'll be the goal. Anyhow, all right, y'all be good.